Hi everyone. So now we will look into the topic of persistent volumes and persistent volume claims. So here in this video we are going to completely understand about the Kubernetes storage, and by the end of this session you will be able to know how persistent volumes work and how persistent volume claims work and what are the storage classes and what is different parameters while creating PVs and PVC storage classes, like different parameters, access modes, reclaim policies do, and how Kubernetes manages storage throughout its life cycle, etc. So many people, in the questions which we have already solved in this playlist. So, like we or anyone will solve using or memorizing YAML files, right? And they create PVs and PVCs, and but during the interviews or any real world troubleshooting, they struggle because we because if we don't understand what is actually happening in the background. So that is why I want to cover this topic in the scene. So why, first of all, why do we need persistent storage? So basically, why we need persistent storage? From the name of persistent volumes, we have got that what is it, persistent, right? So before talking about the persistent volumes, let's understand the problem. Okay, so imagine that we have created a pod. Okay, so this pod, let's understand that first. We have created this pod, and this pod is having a container which is running Nginx. Okay, and that is application which is hosting it, and then the container is started and everything is looking fine. Okay, but what happened, you want to enter something inside this container, so you will do some docker bash docker exec -it some container name, and then bash, and inside that you will try to enter some message into that container, like let's say hello into that any location, let's say like user share something like nginx file. Okay, so now what happens here, when the container is restarted or the pods are restarted, the information inside the container will be vanished. You can again go into the docker using this command and check in this location. You will not be able to find this message because that will be vanished once the pod is restarted or the docker is restarted. But we know that inside the world of Kubernetes deployments and all, the restarts are very common, right? In the world of dockers, the restarts are very common. So whenever you have restarted, if the data is vanished, then what is its purpose in a production ready environment? It will be very hectic, right? So what if the pod crashes or there is too much load and it want to replicate or it want to reload it? So in such cases it will be very hectic, so the file will be gone, and this happens because the containers are designed to be ephemeral. So the containers are ephemeral. Okay, and so they're not intended to, that means they're not intended to permanently do a storage of that important data. So for applications like Nginx, that may be acceptable, but what if in the case of databases like MySQL or Postgres or MongoDB, etc.? In that case, what if the data disappear every time once the pod restarts, and what is the use of using this databases? Okay, therefore we need some storage that survives the pod deletion and recreation, right? Even this databases also will be deployed inside a pod only, right? It is deployed as a pod, and it will be run as a pod only. So what if that also the data is not persistent in this also, then we need some methodology to have persistent storage. There comes the problem of the storage. So first thing is that the storage should be persistent, and here this methodology involves two things. One is persistent volumes and second is persistent volume claims. Before explaining this, let's understand a scenario that, let's say you have an application, and this application for this related storage you want to store, and the developer doesn't know like which particular disk is used for storage or which node is responsible. We will have that master nodes and worker nodes, right? So in the worker nodes, like which worker node is responsible for this, and where does the storage particularly come from? Does this come from any cloud environments like AWS, Azure, etc., Azure or NFS, etc., or is it any local file system? So all these things which doesn't need to know by the developer of the application. Okay, so they just want simply a storage for the application. In that case, Kubernetes solves it, having using a two-layer model. Using a two-layer model, that is persistent volumes and persistent volume claims. So what is the persistent volumes in particular? So this persistent volume is the storage provider. Okay, it is something that provides a storage, that is persistent volume. And what is persistent volume claim? This is storage consumer, and this is persistent volume claim. And this separation is extremely important to understand what is what. Okay, so coming into the main topic, so this persistent volumes may represent different things. Okay, that may be a NFS file system, network file share, and Google persistent disk, or Azure disk, or let's say it can be AWS EBS volume, or CSI volume, anything. Okay, so that can be anything. And a PV is created by either an administrator or a Kubernetes, and this can be created by either of these things. Either manually it can be created, or it can be dynamically or automatically created. It can be dynamically created by the Kubernetes, or it can be manually created by the administrator. And like you can take an example from Kubernetes documentation how to create the persistent volume. So it will be like API version as v1 and kind as persistent volume, and metadata, and then spec has the capacity and storage. Yeah, so that these all information will be there. Let's say this will be like 5GI, and some name is something like PV data and all. So this is one thing. So think of PV as an apartment. Okay, something like an apartment, but you can't directly live in the apartment, but you have to claim some a flat inside the apartment, right? Similarly, you can't any resource cannot use directly the persistent volume. Instead, they have to use a persistent volume claim. In that that will be binded to one of the persistent volumes, matching persistent volumes. Okay, So this binding happens if it matches, and accordingly storage will be given to the particular pod or any resource. Okay. Now if I have to specify what are the different components in PV. So first thing is capacity. So capacity, it can mention like this: capacity and storage is 5GI. Okay, this specifies the storage size, and example like this can be of 1GI, 10GI, some 100GI, or 1 terabytes TI, etc. This specifies the storage and maximum storage available. Okay, this specifies this like a maximum storage that is available in a persistent volume. And the second thing is that is regarding the capacity, and the second thing is access modes. In the access modes we have different things like it defines how the storage can be mounted, and this is one of the most misunderstood topic. Okay, so how the storage can be mounted. Okay, this has like types like read write once, read only many, read write many, etc. Let's understand them visually. So read write once means what is that? So let's say a node 1 is writing into it, reading and writing into it, and there is node 2 also which cannot do the same thing simultaneously. Okay, so most of the cloud related files is cloud related storage system follow this access mode, read write once, like AWS EBS and Azure disk, Google persistent disk, etc. Okay, and there is second thing is read only many, right? Here we have like multiple nodes can read and nobody can write. Example, node 1 can read it, node 2 can read it, and node 3 and so on. Multiple things can read it, and only read only, right? So it is not allowing the write option. Then there is read, write and many. That means it is allowing both the read and the write from all the nodes. So in such case it is allowing simultaneous read and write. Let's say an example for this is NFS file system, EFS, and yeah, that's all. Still there might be there. Okay, so this is all about persistent volumes, important parameters like capacity and access modes, etc. Now there comes persistent volume claims. So what is this? So imagine that we have a PV, but how application can use it, as I earlier mentioned it, it has to request using PVC, which is like essentially like a storage request. Okay, so that means using this PVC, the application can request to a PV. So it's like you don't create a room, you just or you don't create a storage, you will request a storage, right? So that request will be done using this PVC. So PV is generally an actual storage and PVC is a request to that storage which will be done by one of your applications. So you will create a PV, or Kubernetes will create it dynamically, and you will write a YAML file for PVC, that what you are requesting. If this PV can be matched or binded with PV, the PVC, when will this bind? Okay, before that let's see What are the basic what is the basic YAML file for PVC? Okay, it just looks like it has a fields similar to that, like API version, kind. API version will be like v1, kind will be like persistent volume claim, and then there is metadata, and then there is something name under it, and then spec. Here you have some access modes, and here in this access modes we have like let's say read write once, and I will just write it here: read write once. And then we have, let's say, resources, and then there is request as well, and storage 2GI, resource request 2GI. So if you see this PV, you have capacity storage 5GI, right? And you have access modes also, like read write once, read only many, read write many. Similarly, you have access modes here, like read write once, read only once, and read only many, and read write many. So similar access modes also you have, and you will be having the resource request, this thing also. So first thing is this PVC's resource request. Whatever you are requesting, that amount should be less than the PV's storage request, right? So here storage capacity is 5GI. If you request for 10GI, how can the 10GI provided by PV? Because it is only not having the maximum is only 5GI. It cannot provide up to 10GI, right? So then in that case, this PVC will not be binded with the PV if it is like more than the available capacity storage. So that this PV's storage should be less than or equal to PV's capacity storage. And second thing is the access modes also should has to match. So this access mode should be same as the PV's access modes. In that case only the PVC will be binded to a particular PV. Okay, and once it is binded, then only it is going to reserve the storage, and in that state we have we can use this PVCs in the YAML files of resources we create. And now let's come to the next topic, which is life cycles of PV. So what are the different life cycles of PV? We have available, we have bounded, we have released, and we have failed. So what are the different differences between them? So available means when a PV is not basically used by any PVC, right? It is not binded yet, and that specifies that it is available. Okay, so that is one thing. And then bounded means, once I told you, right, once you create a PVC and it found the matching PV, it just binds it. So that is a bounded state of the PV. And then you can just do like key get PV PVC. We'll see in the practicals. So released means you have created a PV, and you have created a PVC as well, and PVC is binded with PV. Now there is no need of this PVC. Once your resources are deleted, you want to delete this PVC as well. So in such case, when you delete this PVC, now based on certain things like reclaim policies, so you will see reclaim policies. Okay, based on these, sometimes what happens, it will, so see, this available state is when there is no PVC is bounded, right? and this state is when it is bounded. So when you will come to released state, when it is bounded and when you remove this PVC, still some of the cache kind of thing will, or in some information that I have passed with this PVC, that will be present in the PV. Okay, so in such case it will be in the released state and you can't use this PV by another PVC, even though like it is like a dangling state. Okay, so in order to, why you will go into this state, why can't you go directly into available state? Even that condition also can come. So you first bounded, then released, then available. That is one thing. First bounded and then available also can come according to reclaim policies. So first I'll explain some reclaim policies to make you understand on this. One thing is you have retain reclaim policies. Second thing you have is delete. Third thing you have is recycle. So basically retain means when you see you are deleting this PVC, still that information somehow like a cache or something, it will be present inside PV. Okay, you can do like k get PV -o YAML, something like that, or k edit PV, like that. You will be able to see some of information of the previous PVC. So direct, when you delete that lines inside the PV YAML, then that PV will be available to PVC. Until then it will be going to released state only. Okay, so once it is bounded and when you delete PVC, then PV will be going to the released state. It is not going to be available. And once you delete some cache kind of, not cache but some lines, okay, those things, then it will go to available state. That is regarding the retain. And why do we need that much process? Because here during this state, if you want, you can take a backup of the previous storage. So that's why you will use this kind of reclaim policy. Now there is delete reclaim policy as well. What does this do? When you use this kind of reclaim policy, after it is bounded, once you delete the PVC, that is going to be going available state. It is not, it's just available, directly available. You need not remove that information in the YAML like that. It will be directly available. Okay, that is delete reclaim policy. Whenever you don't need any backup to take when during its deletion, and that in that case you will use that delete reclaim policy. And then you have the recycle reclaim policy as well, which is also basically volume will be wiped and returned to the available state. Historically it is supported, but now it is rarely used today. It is mostly deprecated, this recycle reclaim policy. So that way you have different kinds of life cycles. And also whenever you are specifying any volume modes, here you have like file system volume mode and block storage, right? So you can, file system means you can directly give the path of the nodes system. Okay, in the inside that node, at which location you are going to use it as a storage, you can directly give that location. That is file system. And application sees the files and folders in that location. Okay, most workloads use this. But whereas this block storage means it's like a raw block device will be there, and that will be exposed as the storage, and application will manage to use this block device directly. And it is common for databases and any high performance workloads. So these are designed basically for the storage systems like databases and high performance workloads. Then there is a topic called host path. You will be able to see this host path when you are creating the PVs or something like that. So what does this mean? This host path is also specific to a file system. Okay, so it is also a node specific, and if pod moves to another node, the storage may disappear, right? So let's say like this, the file system host path and path, and for let's say that node 1 is having this location, but node 2, generally all the nodes will not have the identical files, right? So generally if a node changes, this also disappear. Okay, this file system. And basically this host path maps a directory from the node, like this particular directory. Now until now, whatever you have seen PVs, that is belonging to a class called static provisioning. So basically there is storage provisioning, two types. One is static provisioning and second is dynamic provisioning. So under this static provisioning is what you have seen, the PVs, and now you will see the dynamic provisioning. Under this we will have something called as storage classes. So basically what is difference between static and dynamic provisioning? Static provisioning is that first you will decide, okay, this much is the storage, and that means storage is already specified, and later you will create a PVC that requests to use that storage. Okay, because that predefined. Okay, this much storage is predefined. That means static provisioning. Whereas when you come to dynamic provisioning, what does that mean? Once you will just create a PVC, and this automatically create a storage. Okay, so basically there is a concept called storage classes. This is also one of the YAML files you have to write to create. So instead of PVs, you will write for a storage class. Okay, here you will use a PVC, here also you will use PVC. So this PVC will access the storage class, and this storage class will create PV. This is like 3-step process. This is two step. So the storage class, inside the storage class you can specify which provider will do this dynamic provisioning. Like generally cloud providers like AWS, Azure, etc. will do this. So you can specify that particular providers in storage classes. Once the PVC is created and it accesses the storage class, dynamically the storage will be provided. Doesn't mean like binding to a particular PV with PVC, and that static provisioning is not there here. It is dynamic provisioning, and it's a modern approach. And so coming to storage classes, again we have different templates like fast storage, slow storage. Okay, premium storage, standard storage, etc. And each class may differ with having different disk and different performance levels. Now as I have mentioned that there can be different provisioners like AWS, Azure disk providers, and GCP cloud, Google cloud providers, etc. And without this provisioner, dynamic provisioning will not happen. And even in this there are some parameters like parameters. So there is one section here in the YAML files called like parameters, and here you will see like type gp3 IOPS, etc. Generally determining the storage performance. And you will also see something called volume binding mode. And in this volume binding mode you will also see like two options basically. One is like immediate, and second is wait for first customer. Okay, so what does this mean? Let's see. So immediate means whenever you create a PVC, automatically the volume gets created within just the creation of PVC. But wait for first customer, consumer, sorry. Wait for first consumer means, I'm really sorry. Whenever you create PVC, immediately the volume is not created or storage is not created. Once there is any pod or any resource that is using this PVC, then only it confirms that okay, now we can create the storage because the pod is needing this. Then it creates the storage. Okay, so in that way it helps the Kubernetes to correctly place the storage in correct availability zone, which is very important in cloud environments. So this way we have covered different topics regarding PVs, PVCs, and that comes under static provisioning, and storage classes under dynamic provisioning. And we have seen that what are different attributes we can encounter during this storages. And most production issues will come mostly different access, because of different access modes or mismatch, or storage classes mismatch. Let's say PV will offer RWO, read write only, and PVC request read write many, then binding fails. Let's say you have a storage class, PV uses standard storage class, PVC uses a premium storage class, still then also binding fails. Or capacity mismatch, PVC is requesting more than the capacity of PV that can provide. As we can see that 10 GI, which is more than the existing capacity for PV. In that case also there will be a capacity mismatch, the binding fails. So that way you can debug like why the binding is failing and what are different issues related to it. Let's say the PVC is deleted but PV is stuck in the released state, it is not available. So then administrator must have to claim the references. So you will see a section, I'm saying right, like cache, it's not that. So if you open the YAML file which is already created for particular PV, after it is after PVC is deleted, you will find a section or attribute named like claim references kind of, that is referring to the old PVC, which you have to remove it in order to make the PV available from released status. So that way you can claim it. Now we have seen the real production flow, how it works. So basically when you create any application pod and it is using a PVC, and the PVC let's say is using a storage class for dynamic provisioning, and this storage class is creating a PV on the fly, which is requesting a particular cloud disk like Amazon EBS or EFS or GCP cloud or Azure, whatever that is the provisioner, and then it goes to provisioner and the storage is provided. So this way the chain works in dynamic provisioning. So if any layer breaks, the storage problems will occur. Understanding this flow is really important. So as a summary, here in this video we have seen about what persistent volumes, how they represent the actual storage. We have seen about PVC, persistent volume claim, which represents the request for the storage, and storage classes, we have seen that role of the storage classes in the dynamic provisioning, and we have also encountered what are the different access modes and how they are important for binding of PVs, PVCs, which can mount to the storage basically. And we have also seen about volume modes, how they can represent, like whatever it is, the block storage or the file system storage. And so these are the things, and reclaim policies determine what happens after the deletion, like retain or delete or recycle. We have seen the three different reclaim policies. We have also seen the PV life cycle, like available, bounded, released, and fail, etc. So once you understand these topics, solving PV and PVC questions becomes very straightforward, because every YAML field is having some purpose, and every Kubernetes action follows a predictable storage lifecycle. So that's all from my end on this topic of PV and PVC. Signing off. Bye bye. Thank you.